Hello students, today I am going to start lecture 4th of unit 2nd, that is solutions, class 12th, and today's topic is solid solutions. As we have studied about different types of solutions, where we have studied liquid solutions, solid solutions, and gaseous solutions. In liquid solutions, the main component, that is the solvent is liquid. In solid, solvent is solid, and in gaseous, solvent is gas. It means that the major part of the solution determines its physical nature. So, in solid solutions, the major part is solid. And in fact, in solid solutions, both the components of the solution are solid. Solid solutions are those solutions in which both the components that is solute as well as solvent are solids. There are two types of solid solutions. There are two types. First is substitution solid solutions, and the second is interstitial solid solutions. Solid solutions. So let's first talk about substitution solid solutions. I'll write in short form to substitution solid solutions are those solutions in which atoms, molecules or ions of one substance take place the atoms of another substance. For example, this is a crystal lattice of one type of substance, and now I will show you that another substance takes place of that substance. That substance takes the place of other one. So here this part which is in large quantity is solvent, and this is solute. Or rather, I will write it like this. Here you can see substitutional solids, where you can see that the red ones take the places of the blue ones. Or here we can see that this green part is solvent and the red part is solute. So in substitution solids solutions, atoms, molecules or ions of one substance take the place of another substance in a crystal lattice. And the example for this is brass, where copper and zinc, copper and zinc are mixed together. Other examples are bronze, steel, etc. Now let's talk about the second type of solid solutions, that is interstitial solid solutions. In interstitial solid solutions, the one substance placed into the voids or interstitial spaces between the lattice. For example, here the other substance occupies the voids between the atoms of one substance. The example for this is tungsten, carbide, where tungsten atoms are arranged in face cubic center pattern and carbon atoms in octahedral holes. Carbon atoms in holes. Here, the carbon atoms are solute atoms, and whereas the tungsten atoms are solvent form. So, solid solutions are those solutions in which both components, solute and solvent, are solids. Now, before talking about solid solutions, let's know about the solidification. What is solidification? Solidification is the process of transformation of liquid phase to a solid phase. So, solidification is the process of transformation of a liquid phase to solid phase. वो प्रोसेस है जिससे लिक्विड फेज को हम सॉलिड फेज में ट्रांसफर कर सकते हैं. What is required for this? It requires heat removal from the system, and metals have a melting point above which liquid is stable and freezing point below which solid is stable. Solidification is very important process as it is most widely used for shaping materials to desired products. Now, solid solutions. A solid solution is formed when two metals are completely soluble in liquid state and also completely soluble in solid state. In other words, when homogeneous mixture of two or more kinds of atoms of metal occur in solid state, they are known as solid solutions. तो सॉलिड सॉल्यूशन क्या है? जब दो मेटल्स जो कंप्लीटली सॉल्युबल हों आपस में, लिक्विड स्टेट में भी और सॉलिड स्टेट में भी, तो वो एक होमोजीनियस मिक्सचर बनाते हैं दो या दो से ज़्यादा किस्म के एटम्स को मिला के, और वो सॉलिड स्टेट में पाए जाते हैं. दे आर आल्सो नोन एज सॉलिड सॉल्यूशंस. द मोर abundant atomic form is referred as solvent and the less abundant form is known as solute. For example, sterling silver contains 92.5% silver and remaining copper is a solid solution of silver and copper. In this case, silver atoms form solvent, whereas copper atoms form solute atoms. Now, types of solid solutions, as we have studied earlier. Solid solutions are of two types: substitution solid solutions and interstitial solid solutions. So, substitution solid solutions, if the atoms of the solvent or parent metal are replaced by a crystal lattice, in the crystal lattice by atoms of solute metal, then the solid solution is known as substitution solid solution. क्या मीनिंग इसका कि पेरेंट मेटल जो है, जो मेन मेटल है, उसके क्रिस्टल लैटिस से कुछ एटम्स अगर कोई दूसरा मेटल रिप्लेस करता है, जिसको हम सल्यूट बोलते हैं, जो लेस क्वांटिटी में है, तो that type of solids are known as substitution solid solutions. For example, copper atoms may substitute for nickel atoms without disturbing the F.C.C structure of the nickel. Here, substitution solid solutions. As I have told you, these atoms are replaced by some new atoms. That is the parent atoms. That is the copper. Copper is the solute. Copper atom replaces some nickel atoms. These are copper atoms in yellow, and in white are the nickel atom, and copper atoms replace the nickel atoms. In substitutional solid solutions, the substitution can either be ordered or disordered. In disordered form, solute atoms have substituted disorderly for the solvent atoms, and in ordered form, solute atoms have substituted in orderly manner. As we can see here, this is an disordered form, but this one is ordered form. Solute atoms are replaces the parent atoms in well ordered form. Now, the second type is interstitial solid solutions. In interstitial solid solutions, the solute atoms does not displace the solvent atom, but rather it enters one of the holes or interstices between the solvent atom. An excellent example is iron carbon system, which is shown in the example. Here, solvent atom is iron and solute atom is this one, carbon atom. Carbon atom stays in interstitial spaces or holes in between the iron atoms, and this is example of interstitial solid solution. That's all, students. Thank you.